All right, so we're going to pick up with problem number 37. Yesterday we finished through problems 36. So for problem 37, we're going to convert from one form to another, and we're given an equation in vertex form, and we're going to write it in standard form. In order to do that, what we need to do is multiply the x minus 4 squared, and then distribute the 1/2 and combine our like terms. So to multiply out x minus 4 squared, one way we could do that is the box. You could also use FOIL. You could also use the shortcut. So 3 ways that you could actually multiply this out. Remember, x minus 4 squared means x minus 4 times x minus 4. And so we take x times x, gives us x squared. X times minus 4 is minus 4x. Minus 4 times x is minus 4x. And minus 4 times minus 4 is plus 16. Combining our like terms, minus 4x plus minus 4x is minus 8x. So what we have is 1/2 times x squared minus 8x plus 16 plus 7. And now we're going to distribute that 1/2. So we get 1/2 x squared. 1/2 times minus 8x is minus 4x. One half times plus 16 is plus 8. And then we have the plus 7 at the end. Final step, take the 8 plus 7. And that gives us 15. And there's our answer in standard form. All right, another one to go to standard form, but now we're starting in vertex form. So for this one, very similar to vertex form, the first thing we're going to do is multiply the x plus 7 and the x minus 4. And so I'm going to do that with the FOIL method this time. So we take x times x, x squared. X times minus 4 is minus 4x. 7 times x. And 7 times minus 4. I would combine like terms next before distributing. This makes it a little bit easier. Minus 4x plus 7x leaves me with plus 3x. And the minus 28. Distribute negative 2. And we get negative 2x squared minus 6x plus 56. All right. The next conversion we're going to make, we're going to go from standard form to intercept form. And the way we're going to do that is by factoring. So again, there is that flow chart on page 8 of your packet. So if we follow that, is there a common factor? In this case, there is. And I'm going to factor out negative 3. If I factor out negative 3, I would have x squared minus x minus 20. And the reason I want to take that negative out, we want the x squared term to be positive. Then I can use the X method, find two numbers that multiply to -20 and add to -1. And after thinking about it a little bit, I know they both have to be, one has to be positive, one has to be negative. And so I believe 4 and -5 work. And that's intercept form. All right. The path of a ball launched in the air is modeled by the equation h of t equals -16t squared plus 24t plus 5, where h is the height in feet and t is the time in seconds. How long does it take the ball to reach its maximum height? Remember, that's the x coordinate of our vertex. And then what is the maximum height? That's the y coordinate of our vertex. So really what it's asking us is find the vertex. So to find the time it takes, I'm going to use the axis of symmetry formula, which says take the opposite of b divided by 2 times a. So this would be -24 over -32. And that would be 3/4 or 0.75 seconds. All right, so then what I would do is take that and plug it into my height equation. So we have -16 times 0.75 squared plus 24 times 0.75 plus 5. And so if I plug that in and make that calculation, I find that the height is 14. And again, we were measuring in feet. It's always good to label. The last part of chapter 8 were our 3 different types of functions: linear, exponential, and quadratic. I'm going to leave the graphs for you to do. But here we're going to talk about tables. And one way that you can start is find the difference, the first difference. Take 2 minus -3, that's 5. 7 minus 2 is 5. 12 minus 7 is 5. First differences are the same. By definition, that's linear. If I try that with the second one, first difference is 3, then 6, then 12, So it's not linear. Try the second difference, 3, 6. The second difference is the same, so it's not quadratic, which means our other option would be exponential. And I just want to make sure that it's exponential. If it's exponential, if I multiply a y value by the exact same amount, I should get the next y value. So here I could multiply by 2. And 3 times 2 is 6. 6 times 2 is 12. 12 times 2 is 24. That's correct. That's exponential. And now for the last table, one hint that it might be quadratic. We have 2 y values that are exactly the same. So it has that symmetry, but let's check second differences. 1 minus 2 is -1. 2 minus 1 is +1. 5 minus 2 is 3. 1 minus -1 is 2. That doesn't look much like a 2. And 3 minus 1 is 2. Second differences are the same. That's quadratic. The other representation we will look at is as a function or an equation. Are they linear, quadratic, or exponential? This first one, we have x in the exponent. When x is in the exponent, it's exponential. Letter B, x is to the first power and y is to the first power. I don't have any exponents. If I don't have any exponents, it's linear. And finally, here I have a 2 in the exponent. If I have something squared, that's quadratic. So make sure before your final for the trimester, you finish up all of the non-starred problems and have that ready for me to check on either Wednesday or Thursday, depending upon when your final is. Good luck, and I will see you in the next day or two.